right here. Here, what I'm going to do is I'm going to use mesh analysis to find out all the currents. Let's say this is I1, and let's say this is I2, and let's say this is I3. You can assume any direction. You can do it clockwise or counterclockwise. It's up to you. Everything's going to give the same answer. Okay. So I'm assuming all of them are clockwise. So first, I'm applying the KVL at loop 1. KVL at loop 1, or let's call it an I1. KVL at I1. KVL says that summation of voltage is equal to 0. So here we have I1 going from minus to plus, so this is going to be negative 100, and then plus 8. We can use Ohm's law. Ohm's law says voltage is equal to current I times R. So the current going through this one is I1, and this resistance is 8. So this is going to be 8I1. And then here we have, so this is plus minus right here, and then here it's going to be plus minus when it goes through this. And this is a 4 ohm resistance. So we are going to have 4 times I1, and you can see I2 is coming in the opposite direction. So we're going to have minus I2 here for it. The next thing is, okay, so that's it for the loop 1, because we don't have any other voltage here. So all of these are equal to 0. And if I simplify this one, this is going to be minus 100 plus 8I1 plus 4I1 minus 4I2 is equal to 0. And let's add the like terms. So this is going to be 8 plus 4, that's 12I1. 12I1 minus 4I2, that's equal to 100. This is my equation number 1. Okay, let me write the equations separately because I'm gonna need some space, so I have to erase and redo, so like use this space for something else. So I'm gonna write the equation number right here, number 1 right here. 12I1 minus 4I2, that's equal to 100. This is my equation number 1. Okay, let's use the KVL at loop 2. KVL at I2. If we use KVL at I2, what are the voltage we have? We have voltage across this 4 ohm resistor. So when current goes through here to here, this is going to be plus minus right here. So this is going to be 4I2 minus I1 is going in the opposite direction. So this is going to be I1 minus I1. And then through the 2 ohm resistor, current goes like this. So this is going to be plus 2I2. And then through the 3 ohm resistor, it's going to go like this. So that's going to be plus 3I2. But if you see, the I3 is going opposite direction, right? So minus I3. So that's equal to 0. And if I expand and simplify, this is going to be 4I2 right here. And then we are going to have minus 4I1. And then plus 2I2 plus 3I2 minus 3I3. That's equal to 0. Let's add the like terms. Minus 4I1 plus 3 plus 2, 5, 5 plus 4, 9, 9I2 minus 3I3, that is equal to 0. Okay, so this is my equation number 2. Let me write that one here as well. Minus 4I1 plus 9I2 minus 3I3, that's equal to 0. This is my equation number 2. Okay, let me erase this and do the KVL at loop 3. Okay, let's use a different color. KVL at I3. So I3 is going through this 3 ohm resistor. So here we're going to have plus minus like this. So 3 times I3. I2 is going in the opposite direction, so minus I2. And then here we have this I3 going in this 10 ohm. So here we're going to have plus minus. So this is going to be plus 10 I3. And if you look at this 8 ampere right here, this is going in the counterclockwise. It's coming like this. So it's going to feed the resistance. Like here you can see I3 also going in, 8 ampere also going in. So both are in the same direction. So it's going to be plus 8 here. You see this is a plus 8 because this is in the counterclockwise. So when you counterclockwise and this one is clockwise, they both travel in the same direction. So that's why we have plus 8. And then the next one is I3 is going through this 5 ohm resistor. So this is going to be 5 I3. That's equal to 0. So let's expand and simplify this one. This is 3 I3. And then 3 times negative I2, that's negative 3 I2. And then plus 10 times I3, that's 10 I3. And then 10 times 8, that's 80. Plus 5 I3, that's equal to 0. Now let's add the like terms. We have 3 I3, 10 I3, and 5 I3. 10 plus 5, 15. 15 plus 3, 18. 18 I3 minus 3 I2. Okay, 18 I3 minus 3 I2 plus 80 is equal to 0. Or you can say those are equal to minus 80 as well. Both of the way you can express. Okay, so we done all this thing. Now let's see how many unknown variables. We have I1 unknown, I2 unknown, I3 unknown. So we have 3 unknown variables, 3 equations. So now you have to plug and play. You can do elimination method. To do the elimination method, what you do, you equate 2 of these equation and try to eliminate one thing, and then you can do substitution. So you can try many different method and solve for it. If you solve for it, you're gonna get this answer. I1 is equal to 9.26 A, and then I2 is equal to 2.79 A, and then I3 is equal to minus 3.98 ampere. And this is the final answers. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.